Hello everyone and welcome back to the channel. I'm so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today, we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about rational functions and partial fractions. This lesson is suitable for SHS 1 and SHS 2 students. Now, I know that when you hear the words rational functions or partial fractions, you might feel a little nervous. Many students find this topic challenging because there are many rules and forms to remember. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define a rational function and identify its structure. You will learn how to determine the largest possible domain of a rational function. You will learn how to determine the range of a rational function. You will learn how to decompose proper rational fractions into partial fractions. You will learn how to handle 3 types of denominators: distinct linear, repeated linear, and irreducible quadratic factors. And finally, you will learn how to identify and convert improper fractions before applying partial fractions. That is a lot, but we will take it one piece at a time. Let us start with section 2, rational functions. What is a rational function? A rational function is a function that can be written as the ratio of 2 polynomials. Let us call them P of x and Q of x, so we write f of x equals the fraction P of x over Q of x. There's a very important rule here. Q of x must not equal 0. This means the bottom part of the fraction, the denominator, cannot be 0. Why? Because you cannot divide by 0 in mathematics. It is undefined. Now, let us talk about the largest possible domain. The domain is the set of all real values of x, for which the function is defined. In simple terms, these are all the numbers you are allowed to put into the function. For rational functions, the function is undefined when the denominator is 0. So to find the domain, we need to find out which numbers make the bottom 0, and then we exclude them. Here is the method to find domain. Step 1. Set the denominator Q of x equal to 0. Step 2. Solve for x. Find the values that make it 0. Step 3. The domain is all real numbers, except these values. We write this as the set of x belonging to the set of real numbers, such that Q of x is not equal to 0. Let us look at example 1. Finding the domain. Find the largest possible domain of f of x equals the fraction 3x plus 1 over x squared minus 4. Step 1. Set the denominator to 0. The denominator is x squared minus 4. So, we write x squared minus 4 equals 0. Step 2. Solve for x. We can factorize x squared minus 4. It is a difference of 2 squares, so it becomes open bracket x minus 2 close bracket. times open bracket x plus 2 close bracket equals 0. This means either x minus 2 equals 0 or x plus 2 equals 0. If x minus 2 equals 0, then x equals 2. If x plus 2 equals 0, then x equals negative 2. So the values that make the denominator 0 are positive, 2, and negative 2. Step 3. State the domain. The function is undefined at x equals 2 and x equals negative 2. So we cannot use these numbers. The domain is the set of all real numbers, x such that x is not equal to 2, and x is not equal to negative 2. Please write that down. It is important to state what x cannot be. Now, let us talk about finding the range. The range is the set of all possible output values. We often call this y. These are the answers you can get out of the function. Here is the method. Step 1. Let y equal f of x, so write y equals the fraction. Step 2. Make x the subject of the formula. This means rearrange the equation until you have x equals something with y. Step 3. Identify values of y that make the new denominator 0 or make the expression undefined. For example, if you have a square root, the inside cannot be negative. Let us look at example 2. Finding the range. Find the range of f of x equals the fraction 2x plus 1 over x minus 3. Step 1. Let y equals the fraction 2x plus 1 over x minus 3. So we write y equals 2x plus 1 divided by x minus 3. Step 2. Make x the subject. We need to get x alone. First, multiply both sides by open bracket x minus 3 close bracket to remove the fraction. We get y times open bracket x minus 3 close bracket equals 2x plus 1. Now expand the bracket on the left. Y times x is xy. Y times negative 3 is negative 3y. So we have xy minus 3y equals 2x plus 1. Now we need to group all the x terms on one side. Let us move the 2x to the left and the negative 3y to the right. Subtract 2x from both sides. Add 3y to both sides. We get xy minus 2x equals 3y plus 1. Now factor out x on the left side. X times open bracket y minus 2 close bracket equals 3y plus 1. To isolate x, divide both sides by open bracket y minus 2 close bracket. So x equals the fraction 3y plus 1 over y minus 2. Step 3. Identify restrictions on y. Look at the expression for x. It is a fraction. The denominator cannot be 0. The denominator is y minus 2, so y minus 2 must not equal 0. This means y must not equal 2. So the range is the set of all real numbers y such that y is not equal to 2. This means the function can produce any answer except 2. Please write this down. Finding the range by swapping x and y is a very useful skill. Now, let us move to section 3. Partial fractions. What is the concept? Partial fractions is the process of breaking down a complex rational fraction into a sum of simpler fractions. Think of it like taking a complicated puzzle and breaking it into smaller, easier pieces. This is very useful in calculus for integration and in algebra for simplification. The general form is the fraction p of x over q of x equals the sum of simpler fractions. Before we start, we must check a condition. Proper versus improper fractions. A proper fraction is when the degree of the numerator is less than the degree of the denominator. The degree is just the highest power. For example, the fraction x plus 1 over x squared plus 3x. The top has power 1. The bottom has power 2. 1 is less than 2, so this is proper. An improper fraction is when the degree of the numerator is greater than or equal to the degree of the denominator. For example, the fraction x squared plus 1 over x plus 1. The top has power 2. The bottom has power 1. 2 is greater than 1. So this is improper action. If the fraction is improper, you must perform algebraic division first. You divide the top by the bottom to get a polynomial plus a proper fraction. You cannot do partial fractions on an improper fraction directly. Now let us move to section 4. Types of partial fractions. There are 3 main types you need to know. Type 1, distinct linear factors. This is when the denominator has distinct linear factors. For example, open bracket ax plus b, close bracket times open bracket c, x plus ver b d close bracket. The form is the fraction equals a over a x plus b over c x plus d. You just split them into 2 separate fractions with constants a and b on top. Type 2, repeated linear factors. This is when the denominator has repeated factors. For example, open bracket ax plus b close bracket squared. The form is the fraction equals a over a x plus b over open bracket a x plus b close bracket squared. Note, you need a term for each power. You cannot just put one fraction. You need one for the power of 1 and one for the power of 2. Type 3, irreducible quadratic factors. This is when the denominator has a quadratic factor that cannot be factorized. For example, x squared plus 1. You cannot break x squared plus 1 into real brackets. The form is the fraction equals a over ax plus b plus the fraction bx plus c over x squared plus 1. Note, the numerator of a quadratic factor must be linear. This means it must be bx plus c, not just a constant. This is a very common mistake. Remember, if the bottom is squared, the top must be x. Now let us move to section 5. Worked examples on partial fractions. This is the most important part. Let us look at example 3, distinct linear factors. Express the fraction 3x plus 1 over open bracket x minus 1 close bracket times open bracket x plus 2 close bracket in partial fractions. On the left, we are left with 3x plus 1. On the right, the first fraction loses x minus 1, leaving a times open bracket x plus 2 close bracket. The second fraction loses x plus 2, leaving b times open bracket x minus 1 close bracket. So we write 3x plus 1 equals a times open bracket x plus 2 close bracket plus b times open bracket x minus 1 close bracket. Step 3. Find constants a and b using substitution. This is often called the cover-up method. To find a, we want to eliminate b, so we choose a value of x that makes the bracket with b 0. That is x minus 1 equals 0. So x equals 1. Let x equal 1. Substitute 1 into the equation. 3 times 1 plus 1 equals a times open, bracket 1 plus 2, close bracket, plus b times 0. 3 plus 1 is 4. 1 plus 2 is 3, so 4 equals 3a. Divide by 3. A equals 4 thirds. To find b, we want to eliminate a. So we choose a value of x that makes the bracket with a 0. That is x plus 2 equals 0. So x equals negative 2. Let x equal negative 2. Substitute negative 2 into the equation. 3 times negative 2 plus 1 equals a times 0 plus b times open bracket. Negative 2 minus 1, close bracket. 3 times negative 2 is negative 6. Negative 6 plus 1 is negative 5. Negative 2 minus 1 is negative 3. So negative 5 equals negative 3b. Divide by negative 3. b equals positive 5 thirds. Answer, we substitute a and b back into the form. The fraction equals the fraction 4 over 3 times open bracket x minus 1 close bracket plus the fraction 5 over 3 times open bracket x plus 2 close bracket. Please write that down. Check your signs carefully. Now, let us look at example 4. Repeated linear factors. Express the fraction 5x plus 2 over open bracket, x minus 1 close bracket squared in partial fractions. Step 1. Set up the form. Since it is a repeated factor, we need two terms. The fraction equals a over x minus 1 plus b over open bracket, x minus 1 close bracket squared. Step 2. Multiply through by open bracket x minus 1 close bracket squared. On the left, we are left with 5x plus 2. On the right, the first fraction loses 1 power of x minus 1, leaving a times open bracket x minus 1 close bracket. The second fraction loses both powers, leaving just b. So we write 5x plus 2 equals a times open bracket x minus 1 close bracket plus b. Step 3. Find constants. To find b, let x equal 1. This eliminates a, substitute 1. 5 times 1 plus 2 equals a times 0 plus b. 5 plus 2 is 7, so b equals 7. To find a, we cannot use substitution easily now because we only have one bracket left. So we compare coefficients. Look at the x terms. On the left-hand side, we have 5x. On the right-hand side, we have a times x, which is a think x, so a must equal 5. Answer. The fraction equals 5 over x minus 1 plus 7 over open bracket x minus 1 close bracket squared. Notice how we needed both terms. Do not forget the first power term. Now let us look at example 5. Irreducible quadratic factor. Express the fraction 2x squared plus 3 over open bracket x plus 1 close bracket times open bracket x squared plus 1 close bracket in partial fractions. Step 1. Set up the form. We have one linear factor and one quadratic factor. The fraction equals a over x plus 1 plus the fraction bx plus c over x squared plus 1. Remember, the quadratic top must be bx plus c. Step 2. Multiply through by the denominator. The denominator is open bracket x plus 1 close bracket times open bracket x squared plus 1 close bracket. On the left, we have 2x squared plus 3x plus 3. On the right, the first fraction loses x plus 1, leaving a times open bracket x squared plus 1 close bracket. The second fraction loses x squared plus 1, leaving open bracket bx plus c close bracket times open bracket x plus 1 close bracket. So we write 2x squared plus 3x plus 3 equals a times open bracket x squared plus 1 close bracket plus open bracket bx plus c close bracket times open bracket x plus 1 close bracket. Step 3. Find constants. To find a, let x equal -1. This eliminates the b and c part because -1 plus 1 is 0. Substitute -1. 2 times -1 squared plus 3 times -1 plus 3 equals a times open bracket -1 squared plus 1 close bracket plus 0. -1 squared is 1. 2 times 1 is 2. 3 times -1 is -3. So 2 minus 3 plus 3 equals a times open bracket 1 plus 1 close bracket. 2 minus 3 is -1. -1 plus 3 is 2. So 2 equals a times 2. Divide by 2, a equals 1. To find b and c, we need to compare coefficients. Look at the x squared terms. On the left-hand side, we have 2x squared. On the right-hand side, we have a times x squared from the first part. And from the second part, b x times x gives b x squared. So the coefficient is a plus b. We know a is 1, so 2 equals 1 plus b. Subtract 1. b equals 1. Look at the constant terms. On the left-hand side, the constant is 3. On the right-hand side, from the first part, a times 1 is a. From the second part, c times 1 is c. So the constant is a plus c. We know a is 1, so 3 equals 1 plus c. Subtract 1. C equals 2. Answer. The fraction equals 1 over x plus 1 plus the fraction x plus 2 over x squared plus 1. This was a longer example, but you did it step by step. Now let us look at example 6. Improper fraction. Express the fraction x squared plus 3x plus 1 over x plus 2 in partial fractions. Zescamps 1. Check degrees. The numerator has power 2. The denominator has power 1. 2 is greater than 1, so this is improper. We cannot do partial fractions yet. Step 2. Perform algebraic division. We need to divide x squared plus 3x plus 1 by x plus 2. How many times does x go into x squared? It goes x times. Multiply x by open bracket, x plus 2 close bracket. We get x squared plus 2x. Subtract this from the original. X squared minus x squared is 0. 3x minus 2x is x. Bring down the plus 1. Now we have x plus 1. How many times does x go into x? It goes 1 time. Multiply 1 by open bracket x plus 2 close bracket. We get x plus 2. Subtract this. X minus x is 0. 1 minus 2 is negative 1. So the quotient is x plus 1. The remainder is negative 1. Step 3, write as quotient plus remainder over divisor. The answer is x plus 1 plus the fraction negative 1 over x plus 2. We can write this as x plus 1 minus the fraction 1 over x plus 2. Answer, x plus 1 minus the fraction 1 over x plus 2. Always check for improper fractions first. It saves you from making mistakes. Now, I want to warn you about common mistakes students make. Section 6. Mistake number 1, ignoring improper fractions. Some students try to split the fraction x squared over x plus 1 directly without dividing first. Correction. Always check the degrees. If the top power is higher, divide first. Mistake number 2, wrong numerator for quadratics. Some students write a over x squared plus 1 instead of bx plus c over x squared plus 1. Correction. Remember, if the bottom is quadratic, the top must be linear, meaning it needs an x term. Mistake number 3, repeated factors. Some students write a over open bracket x minus 1 close bracket squared plus b over open bracket x minus 1 close bracket squared. Correction. You need separate powers. A over x minus 1 plus b over open bracket x minus 1 close bracket squared. Mistake number 4. Sign errors when substituting negative values like x equals negative 1. Some students forget to bracket them. They write negative 1 squared as negative 1 instead of positive 1. Correction. Always use brackets. Open bracket negative 1 close bracket squared is positive 1. Mistake number 5, domain versus range. Some students confuse the restrictions on x with restrictions on y. Correction. Domain is about x, bottom of original. Range is about y, bottom of inverted. Now it is time for class evaluation. Section 7. I want you to pause the video and solve these in your notebook. Question 1. Find the domain of f of x equals the fraction 1 over x squared minus 9. Question 2. Find the range of f of x equals the fraction 3x over x plus 1. Question 3. Express the fraction 4 over open bracket x minus 2 close bracket times open bracket x plus 3 close bracket in partial fractions. Question 4. Express the fraction 2x plus 1 over open bracket x minus 1 close bracket squared in partial fractions. Question 5. Is the fraction x cubed plus 1 over x squared a proper or improper fraction? Explain. Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, section 8, please do these at home. Question 1. Find the largest possible domain of f of x equals the fraction x plus 5 over x squared plus 2x minus 8. Question 2. Find the range of y equals the fraction 2x minus 1 over x plus 3. Question 3. Express the fraction 5x plus 7 over open bracket x plus 1 close bracket times open bracket x plus 2 close bracket in partial fractions. Question 4. Express the fraction 3x squared plus 4x plus 5 over open bracket x plus 1 close bracket times open bracket x squared plus 2 close bracket in partial fractions. Question 5 is a challenge. Express the fraction 2x cubed plus x squared plus 1 over x squared plus 1 in partial fractions. Hint: divide first. Let us do a summary of what we learned today. Section 9. A rational function is the ratio of two polynomials p of x over q of x. The domain is all real x except where q of x equals 0. The range is all real y, except where making x the subject becomes undefined. Partial fractions is breaking a complex fraction into simpler sums. Proper fractions occur when the degree of the numerator is greater than or equal to the degree of the denominator. You must divide first. The forms are linear a over a x plus b. Repeated, a over a x plus b over open bracket 8x plus b close bracket squared. Quadratic, bx plus c over a x squared plus bx plus c. The methods are substitution and comparing coefficients. I know this was a long lesson, but you have done amazingly well. Rational functions and partial fractions can be confusing because of the many forms, but you now have the tools to handle them. Remember, practice is the key. The more you practice setting up the forms and solving for the constants, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there's a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.